Hello everyone, in this video we are going to see how to draw different types of inverters in Proteus. The types of inverters we have learned in the theory part. We are going to demonstrate those circuits in Proteus, and we will verify whether the outputs matches with the theory part we have learned so far. From your lab sheet you can see that task 1 is given here as push-pull inverter. We have talked about push-pull inverters basic in the theory part. If you remember, the basic circuit of a push-pull inverter looks something like this. There were supposed to be a transformer, a DC source and two switches, and we were supposed to collect the output from AB terminal. Now look at this circuit. This is exactly the same circuit we have talked about just now. See, there is a transformer, there is a DC source, and there are two switches, and those two switches will be controlled by these two pulse generators, right? And the output will be taken from this terminal. Now let's move to the Proteus, and I believe you all will be able to draw this circuit in Proteus because there is no complex component used here, and all of the components are pretty simple. And in the previous videos of this lab, I hope you have learned how to extract this component from the library. The only new component that you will need for this experiment is the transformer. So if you write here TRAN to P3S, you will find the transformer that is needed for this experiment, and here is the transformer. If you bring the transformer into this portion, the orientation of the transformer is something like this, and I think you guys are smart enough to use it for in a correct way we need for this experiment, right? You just have to rotate it 180 degree, and then you will be able to use it the way we have shown in the lab sheet, right? And I have connected the output in the C terminal and the two pulses in the AB terminal. One more thing, how the pulse generator will be configured is given in your lab sheets. I think you can do this by your own, right? And if you have drawn the circuit and connected all the connections properly, now you are good to go for the output. If you remember from the theory part, the switches were supposed to be controlled like this way. When S1 will be conducting, S2 will not be conducting. When S2 will be conducting, S1 will not be conducting, and thus in the output terminal we were supposed to have a alternating voltage. Let's see whether we get the similar type of output when we are simulating this circuit in Proteus. If you simulate this and you see the output from the oscilloscope, see, this is exactly what we have shown in the theory part. This graph is coming from the pulse generator 1, this graph is coming from the pulse generator 2, and subsequently what we are getting an alternating output in the output terminal, right? So this is how push-pull inverter is working. Now let's move to the next task from your lab sheet. The next task is the H-bridge inverter without filter. Okay, if you seem to remember, in the theory part we have seen how H-bridge inverter looks like. See, this is how H-bridge inverter should look like. There must be 4 switches and DC source, and the output will be taken from this terminal. See, in this picture we are creating exactly the same thing. From this picture it might look a bit complex. If you look here, see, this is exactly what we have learned in our theory part. There are two switches, there are 4 switches, and 2 switches are controlled by one pulse generator. These 2 switches are controlled by another pulse generator, and this is the DC source, and here is the output terminal. So this is what it has been drawn in your lab sheet, and the components used here are very common, and you have already learned how to use this component in Proteus, and I believe you will be able to create this circuit in Proteus very easily. And once you have created this circuit in Proteus, Now you are ready to go for the output. So if you remember the theory of the H-bridge inverter, two switches were supposed to controlled by one gate pulse, and another two switches were supposed to get controlled by another gate pulse, and the gating pulse were supposed to be configured in such a way so that we get an alternating output in the output terminal, right? So in this Proteus file, see what we have done. We have created exactly that type of a system. These two switches are controlled by one pulse, and these two switches are controlled by another pulse. Now if we look at the output of this simulation, we will see the same thing that we have seen in the theory. See, these are two different gating pulses, and these are configured in this way. And so consequently, what is happening in the output? See, in the output we are getting an alternating voltage, and in the input we use the DC source. So this is working as an inverter, and this is the basic of an H-bridge inverter, right? Now let's move to the next task of your lab sheet, and this is the H-bridge inverter, but the difference here is that it is with a filter. So previously what we used, the output was taken from a simple resistor, but now we are going to take the output from a filtered case. So the output will be taken from a filtered section or filtered system. So this is the filter we're talking about, and what this filter will do, it will filter the output in such a way so that we can have a proper sine wave. Okay, now let's move to the Proteus and see if you can draw the circuit. I believe you will be able to draw the circuit, and here is all the filtering portions. So if you can draw this circuit and simulate, see what you are going to have in the output. You are going to have a proper sine wave in the output, and this is the filter. This filter will work as a low pass filter, and thus it will give us a sine wave. And how this filter will give us a sine wave? I think you all know that in a let's see this section. See, without the filter, what we were supposed to get? We were supposed to get a pulse wave. So if you have the knowledge of Fourier series, so you know that in a square pulse we do not get even harmonics, we only get odd harmonics. So the odd harmonics might look like this. So the odd harmonics will be of different frequencies. If you only let the lowest frequency to pass through our filter, we were supposed to get this as an output, right? So this is exactly what we have done here. We were supposed to get this pulse, but we have filtered out all the higher odd harmonics, and we let the only lowest possible frequency to pass through, and consequently what we have got here, we have got here a proper sine wave. See, that's what the filter does here. So this was it. This was the experiment 4 of your power electronics lab, and I hope you will be able to understand what has been demonstrated in this lab sheet and all these things. Thank you very much, and that's it. That was from my side.